We will try to browse, in fact, the whole spectrum of demonstrating, learning, and evaluating socio-communicative behavior for human-robot interaction. So just a preamble, forward. I think we have, as we have already discussed in the previous presentation, to give to this robot skills for mind reading, in fact, the humans, but also to my argument is that you have to, this relationship should be reciprocal. So, in fact, the robot should be also mind read by humans. So, what is happening in his brain, or his memory, or his computer, it should be also accessible, or in a very implicit way by humans. So I strongly disagree with arguments I've read in the press recently about asymmetrical interaction. Because we have incredible mind-reading abilities of robots with recent artificial intelligence and Internet of Things. And it's not only the robot, it's also the robot has access to what is surrounding us, the social networks, all the sensors, and which could be disseminated in your environments. So it could know a lot of things, perhaps better than just human partners. I've been, working on a project and in Singapore about trying to follow elderly people in the city. So they collect a lot of information of where the people. So of course a lot of supports and credits, a lot of people also involved in it. I will not mention everybody separately. So the outline of the talk, I will just introduce, I think, two things we have in mind about social robotics is this concept of short-term and versus long-term interaction, which in fact gives very different constraints on how to build, in fact, the behaviors. The problem of acquiring social behaviors. Most of the time we just observe human beings behaving. The problem is how to map or to transfer this human-to-human demonstration to human-robot interaction. So I will claim for embodied demonstration, we're using immersive teleoperation, I will describe to you. I will just introduce an NR project, which is very inspiring for us. I will present to you Nina, so this the iCub, the specific iCub we have at the lab, the beaming platform, what we have done on learning multimodal behaviors, and give you some videos about what the fine details and the details are. The devils are in the details. So anyway, social robots, there is a lot of variety of embodiments from. This is somehow a robot. It's hair. A movie hair. As soon as you have a voice, you have something. You have an embodiment. The voice is supposed to be output by the body. We associate everything with some. We cannot avoid to project a voice towards a body. That's also from Amazon stuff to paper to very strongly embodied Geminoid's project. And of course, a lot of embodiments, abilities, so degrees of freedom, displays, and so on, and roles, which are enabled by these embodiments. Just to introduce, in my opinion, there are two kinds of social human-robot interaction. What I call long-term interactions. I think Catherine will speak about this next. So there are concerns about building a very long-term social rapport between two persons. So it's dedicated to few users, perhaps mainly one face-to-face, perhaps with a family, but well-identified users. You can acquire across time knowledge about common experience. It's most of the time a private environment, home, with a lot of ethical problems we can discuss this evening. Most of the time it's narrative, free conversation, endless conversation. And the objective is really to build social glue and affective relations. Another aspect I'm more keen to work on, that's our field of work, it's short-term interactions. The idea is that you have to adapt to many users. For example, if you are training or you are conducting interviews, you are supposed to face millions of people which have no pathological behaviors or strong pathological behaviors, which range from age to very young people to elderly people and so on. So you have to, the key issue is really to be able to adapt in a few minutes to with some a priori, to this large variety of partners. Most of the time, it's in contrast with private, it's a more professional environment. Robotics, interview in medical settings and so on. So it's most of the time it's task-oriented. When I am welcome in a shop by a robot, I am supposed to sell him or to recommend him some products, which he will find it's not free conversation. You have to earn money at the end, so it's strongly repetitive. Okay, it's an advantage of robot. It's Arbeit, and it's perhaps less effective, but still it requires attention and engagement. The objective is to get the people to get the people involved in the interaction, to keep them interested. So, why endow robots with social behaviors? It's just a few things we can discuss. What I think is interesting is that with robots, the roles could be exchanged. I think that first, because robots have no social status, so robots could be a coach, but you can also think that a robot being just a magic mirror, where you ask him to reproduce what you are doing and so on. So it's not like a human coach with strong muscles and so on, where you can't imagine this very healthy person asking an elderly person to say, could you show me a movement? No, it's, I'm a coach, I demonstrate you, I'm a healthy person, I will show you some Tai Chi movements. It's very bizarre, it will be very strange to inverse the role and ask him, so to do some active learning. It has been demonstrated with writing, with some problems dealing with education, that you can exchange roles. So robots have no social status. Robots do not judge. I think the big success of robots has been or is still being with the treatment of autism. So a priori, children, elderly people don't project towards robots strong social expectations about what will be the evaluation of the interaction. Trust, people, in fact, do trust. Seems to be able to trust more robots than they are trusting human beings they don't know. Okay? Perhaps because parents have never said to the children, don't speak to robots. So, and of course, there is a possibility of adaptive complexity of behaviors. You can have very schematic, so you can program or you can instruct a robot to have a very schematic displays. And after, complexify, in fact, the way they can mind read and so on. So, to be able to adjust in a very smooth way, on purpose, the way it's interacting with humans. So, what about acquiring social behaviors? So, most of the time, this idea to train or to be able to maintain the person with socio-communicative skills and so on. So, of course, it's a dual problem. So the idea is to, as it has been shown by Peter, to be able to converge. So it's a dual problem. The robots has to, humans converge towards each other because it's a way, in fact, also to be able to transfer, to maintain, in fact, interaction. So I just gave some example of the success of being able, in fact, this idea of magnet effect. If you are too far away from each other, wherever you move here, there is no big impact on the target. If you move near, you have a magnet effect, and so when you are able to better, in fact, monitor or to influence the behavior of each other. So it has been done with a co-writer idea on the PFL, where children, in fact, trying to teach a robot to write, but in the same time, in fact, the robot imitates the way the children are doing improper letters by correcting, so by in fact, driving them towards better ways of writing. So this idea of motor resonance that drives both of them good. So this is sensory motor resonance, exploiting the chameleon effect, mutual alignment, and convergence. So if you want the robot to attract the people, the robot has to be near the human, and after being able to draw the human towards desired behaviors, the desired mental state, and so on. So what about acquiring experimentally these social behaviors? So either by programming, by engineers, so either a collection of professional expertise, where you ask specialists, in fact, to encode, in fact, what is written in the books. So of course it's tedious and slow. What about learning? So the robot with some motivation can be part of this learning. Could be autonomously, notably using developmental learning. We will have two examples today. By imitation, observation. So you have humans performing in front of robots, and the robot try to imitate, observe, in fact, and transfer. So there are this imitation and observation, done by imitation of observation, faces a lot of scaling problems, because in fact the sensory and motor abilities of robots are different from humans. Okay, so it's very different how a robot, how a human will be behaving if he is so much impaired as a robot is doing. Of course, the robot has not the same background, the same a priori knowledge to inject into the observations. Another possibility is to do it by demonstration. So it's a well-known demonstration by kinesthetic demonstration. So you take it's well used by notably in robotics, where you take the arm of the robot and you demonstrate how the robot just compensate for gravity, and you demonstrate how to behave passively, and after it just transfers to some active performance. Another way is to that's what I will describe to you. It's doing teleoperation, because you cannot demonstrate how to, for example, gaze or how to speak and so on. So you cannot to say a pilot, a human demonstrator, the human demonstrator cannot embody or manipulate from the outside some organs. So teleoperation demonstrate what we've been performing. And of course, the problem of demonstration is problem of dual user problem, where in fact the demonstrator, the pilot, is both to interact through a robotic embodiment with the environment that comprises the subject, the end user, but he has also to interact with some robotic embodiment, which is not transparent by definition. So the problem of the pilot is really to be able to cope with this dual interaction, where the robot mediation is not transparent. So the idea this idea of human pilot, it has been done with several researchers. So the idea is that the human pilot embodies, in fact, the robots that provides sensory motor mediation, okay, from the local environment towards the remote environment in which the robot is immersed. And the idea is that the human pilot is providing a cognitive gift, okay, by taking the best use of available sensory motor abilities. And so the idea we try to promote is to learn the behaviors by immersive teleoperation, where the professional or human pilot is teaching, in the first place, to a very passive robot the way to behave. So it gives, in fact, demonstration of socio-communicative demonstration to a robot that passively, in fact, mimics, reproduces, in fact, mediates this interaction. So it's, of course, the idea is to, since in fact it's mediating, we solve the scaling issues, that's the commands and the sensory information is adapted or is shaped with regards to the sensory and motor abilities of the robots. But still, you have the problem of embodiment. So you have problems with the pilot, which is these problems of out-of-body experience, with self-location, ownership, agency. So the challenge is really to be able to have a platform which is as transparent, as immersive as possible. So the Sombrero project, so we on this concept of immersive teleoperation or embodied teaching of socio-communicative behavior, we have a Sombrero project. Sombrero project is dedicated to this. So the idea is to provide sensory motor learning through the robot through immersive teleoperation. So the pilot, in fact, senses the remote words through the robot sensors and is acting on with the user through the robot actuators. So communicative gift by pilots. First, a passive experience by robots that in fact build some kind of episodic memory. I will skip this. And from this sensory motor episodic memory, it builds, the idea is to have a sensory motor memory or episodic memory, and the robot builds cognitive behavioral models that hopefully will give you some autonomous behavioral models. So just so the idea is to have, of course, beaming experience. It's called beaming or immersive teleoperation. The concept of beaming has been introduced by Max Slater through a European project dedicated to this experience. And so the idea is to model socio-communicative behaviors and after to drive back to autonomous behaviors. So the task, because as I said, we are aiming short-term interaction with task-specific context. So we want to teach, in fact, a robot to conduct neuropsychological tests, again on memory. So the test we are aiming at is this RLRE, so it's a test about for episodic memory. The idea is to, for the interviewer, is to, so it's an adaptation of the free and Q selective reminding test. So it's screening test. So it's the idea of the screening test is to evaluate the mild impairments of episodic memory, which is supposed to be the beginning of Alzheimer's disease. So if we want to conduct this screening test at 60 years of age, it will be very costly. Okay, it's a highly repetitive test, and it's lasting between 12 and 20 minutes. It has been to be conducted at a large scale with very different person, male, female, with very different education level, different impairments, and so on. Sometimes you have to be very careful, to do a lot of intensive, encourage people, and so on. Or you have some people which are very with no problem of memory, and so on. So and the test is a win in 10 minutes. So you have to adapt, in fact, the test to the person. And so the basic test consists of the immediate and delayed record of 60 words. That's it. So it includes 3 main steps, where you learn the words and categories to the subject. You test the words, the episodic memory, and they retain the words. And after recognizing the words, and in between this task, you have distractors, which increases the cognitive load, consisting of reverse counting, 3,000, 2,900, and so on. So to distract the episodic memory. So what about Nina? So our IQ platform, as you know, is 1 meter high, 53 motors, and we for Nina, so it's IQ 2.0. We redesigned, in fact, the face. We added 5 motors for the lips and jaw. So he has a movable jaw and movable lips. We have a textile cover. It's a rubber. It's rubbing you. He has new ears, so we have pin ears and a microphone in order to work on the audio localization. And we have a new eyelids and iris mechanism. So just to illustrate, I hope that the sound is on.
J'espère que vous trouverez ma voix intelligible, même si je parle parfois un peu vite. Je suis une robot humanoïde du GIPSA. Quand je parle, vous pourrez voir que j'ai en même temps la mâchoire et les lèvres. Je suis terriblement désolée, mais il m'est tout à fait impossible de parler anglais avec vous. Je suis encore trop jeune pour ça. Mais me pardonnerez, j'espère. Et puis j'arrive quand même à dire My Taylor is rich. Pas trop mal, n'est-ce pas?
Okay. So, since we are specialists of audiovisual synthesis, it's our own audiovisual synthesizer. And lip sync is not perfect, but it's a good quality. So we have. It's important when you are building a robot to assess every component. So we assessed the speech intelligibility. In fact, the audio-visual integration has to be better in noise than audio and video only. Okay, so we have done it. So we are for speech and noise. We are just we have shown that it's lacking rounding, like in French, and so on. So we have to do rounding. He's not able to round, and he has a very fragile voicing contrast. It's for speech specialists. Just to mention that we have worked I'm very proud of this. We have worked on gaze direction. You know this, everybody knows about communicative hypothesis. In comparison with all other species which have gaze, the human has a unique morphology of the eyes with 50%, roughly 50% of white sclera, and half of iris, and a very strong contrast between the two. When you, for example, apes, gorilla, and so on, they try to hide, in fact, even because they are predator or prey, they hide their gaze, okay? Because they are still in this seeking for food or to eat animals, others. We are a social species, and so we give for free our mind to read to others. And so when you observe, I didn't show it here, but when you see gaze or morphologies of eyes in robots, current robots, it's a disaster. Okay? Paper and so on, forget. Okay? So the idea is we tested different morphology, and the winner is this one. So we are very sensitive for estimation. So we ask people to estimate the gaze of dinner, not the reverse. And the optimal is this configuration, where you have half sclera, half iris, and when you have also eyelids which are depending on the elevation. Because if you watch down, you look down without moving your eyelids down, it looks like you are frightened. So you can misinterpret, in fact, the robot's mind if you don't do it right. So, blah blah blah. So we observe, just to remind you.
Est-ce que vous pouvez me dire le nom de l'oiseau, la maison, le nom de l'arbre, le tilleul, le nom du sport, le judo, et le nom du légume, le céleri.
Okay, so we recorded, we motion capture real interviews between a neuropsychologist and a different elderly person. 10, I think we were 20, 25 now. So as you have said, we learned 4 words at a time. After, so it's a learning step, 4x4. After you ask for immediate recall.
Est-ce que vous pouvez me redire le nom de l'oiseau? Le nom de l'arbre, le nom du
items. So the idea is how to implement RLI for Nina as an interviewer with social skills. So I think I have to accelerate a bit. So it is, the idea is to do immersive operation, so to learn by demonstration. To do machine learning to connect, in fact, perceptual events to action events, and of course to trigger action with gestural controllers. Look, say this, look at this, point at this, and so on, to trigger appropriate action at the appropriate pace. So the beaming platform. The idea is to have a head-mounted display. So that's the old one, Hamilton Research. So we benefit, we bought SME eye tracker just before it was bought by Apple, where they just closed the lab of the company. And so we have a head-mounted display with embedded binocular eye tracker. That receive, in fact, the gaze, the image which are captured by the camera, which are embedded into the robot eyes. And these robot eyes has 3 degrees of freedom: elevation, azimuth, and vergence. And so just to beam the gaze. So we are mainly interested in the upper part of the body. So we are beaming the gaze, the head motion, the eyelids, the speech, the movement, given the movement of the pilot. So it's just an illustration of the situation where we have here two users, not only one. And this robot is conducting TT, how you say it in English, so practical work for engineer engineer school on electromechanical exercises. So it's a 6-0 building back a 6-0. Anyway, so that's the kind of behavior.
Bonjour, on va faire un test de mémoire. Donc, je vais vous donner des instructions. Je vais vous présenter des
Guys, you don't know that here it's the lips are moving.
Soit par la catégorie, soit directement par le haut. C'est tout bon? D'accord. Donc, je vais vous laisser poser les bras sur la table. D'accord, c'est possible.
And this is by the robot is in fact piloted by Frédéric Elisy. So you can see that there is an independent control of the eyes and the so sorry. Yeah. So just to mention, it's the world prime. In fact, we are the only one in the world so far being able to beam the vergence of the because we have a binocular eye tracker, we have a unique robot with equipped with, so there is an alignment of planets which enable us, but it's not so evident. So we just have a paper accepted at ESL in Munich next June about this. So we are able, and we have been demonstrating that we can by asking different persons to look at the screens with different with objects at different depth between 25 to 1 meter, 25 centimeters to 1 meter, to control effectively and reproduce the good or the appropriate vergence. And that's important because when you are in a closed interaction field, which is especially the case when you are face to face, across the table and so on, vergence informs the interactor that you are effectively speaking about the object which is in between. And this is so estimation that we are working on this, but we are in a good direction. Yes. So what about learning interactive behaviors? So we collect, in fact, events. I had a question about events, but it's a very complex. For us, events are very local events, saying a word, looking at something. So fixation or saccade is an event. So it's this time definition. Of course, you have different scales of events, and what is very tricky is how to, in fact, be able to navigate between these different time scales. But I am a signal processing guy, so I am interested in milliseconds. So how these different events coordinate, and I'm interested in multimodal coordination. And when you say, look at this is very complex. Because you have first to look to locate precisely, point at this, and after you speak. So this coordination, this causal relation somehow, is very important. So we try, in fact, to model this, and of course it's depending on the interaction unit. The way you pay attention to different objects in the scene is depending on the task. Okay? It's well known from Airbus stuff and so on. So it depends on which questions, in fact, you ask to the environment. What do you want to get out of the environment? So we've been interested in the coordination histogram, so how the different events are the causal relations. So we have worked on HMN and SPN. Recently, we conduct a lot of things with LSTM, so this deep neural network which is able to cope with memory or time information. Of course, there is a lot of problems of adaptation issue. And I think one of the key issues for machine learning now is how to model styles. Okay? You have a collection, in fact, of behaviors, but these behaviors are depending on, how to say, a priori or external hyperparameters, which are depending on the pre-established relations, the relation you want to establish with this person, and so on, all the work which is concerned with social signal processing, pen count, and so on. So the way you do speed dating is on 3 minutes. A lot of things are depending on a priori information you have on the person you are facing to, and the goal you are. So 3 minutes, within 3 minutes, a lot of things happens. So it's not only a long-term relation, big U and so on. If you have 3 minutes to get the card of your lady, you have to speed up. Don't have time to establish social rule and so on. And of course, one big issue of this model is incremental issues. To be able to predict or to compute a behavior with very minimal lookup. Right? There is no way to plan. It's too late. Okay, so you need to have models of interactive behavior, which pick up as much information in the past. Okay, because the future will be depending on what you are doing. Okay, and perhaps to have back off possibilities to reconsider your strategy or to switch between models, but I will discuss this afterwards. So of course we have been dealing a lot with, we are mainly, as a lot of people, gluing in fact co-verbal behavior to verbal dialogue. So we have been working on gaze, so what are the gaze patterns during interactions, hand movements, back channeling. We have studied how the people inform, how the robot can inform a person which is actually listening, processing the information the subject has delivered to him, which is very important for. So we worked on styles and so on. For example, even the gaze pattern in a very simple gameplay, I have no time to illustrate this, but with a person, with colleagues and students, the gaze pattern has a signature of these social relations. So you have two different models, or two different class of models, of distance between models. Here you have same-sex colleagues, same-sex colleagues, same-sex students, or male. Okay, so you have different ways, distribution over the face, different timing and so on. So this is capturing all this. It's mainly the distance between models and data. So there is a signature of social relation in the way you behave dynamically. So blah blah blah. We have gesture controller. Looking at to open eyelids and so on, text-to-speech, prosody, intonation, back channels and so on. At the end, blah blah, yeah. So we replace the handbook with the tablet, and that's the kind of behavior we are aiming at. Okay, this fluency of behavior.
Je ne verrai rien, quoi.
Il y avait le nom d'un instrument de musique.
Le harpe.
Très bien. Il y avait le nom d'un arbre.
C'était pas le frais, le chêne, c'était.
C'était tilleul. Oui. Il y avait le nom d'un sport.
Okay, so blinking, the way that you don't fixate so much the person, is in difficulty, you move away, seeing take your time and so on. getting back, doing incentives, and so on and so on. So all this kind of very complex, fine structure of interaction. Sorry. So just I will just want to who has raised a question about evaluation? There was 2 questions about evaluation. What about evaluation issue? How you do evaluate such a behavior? We are very concerned about this, especially to a diagnostic, to be able to pinpoint incorrect behaviors, which are not global. It's not like a note, you say, oh yes, it's okay. No. But for the engineer, for the developer, it's very difficult to have feedback about this. So so we develop a methodology to be able to by crowdsourcing. We ask people to watch a video as third parties and to click. That's what we say. It's, in the literature, it's called yuck response. Bark in French. Bark response. To press the bar space each time something is wrong. Okay, so you have 20 minutes, and each time you say no, he's not behaving very nicely. Dark response. And after we can go back with specialists and also with raters to say, at your advice, what went wrong? Is that the coordination, the time response, the gesture which is performed, and so on. So we collect, in fact, densities across time, densities of yuck responses, and we can focus on the main and to be able to attribute the semantics to this maximum of disgust or improper behaviors. And we demonstrate after 1 year that we were able to, in fact, lower and so what is interesting is that, just to summarize, that we improved the yuck responses, but we degrade the acceptance scores, because people get more exigeant, more demanding on the behavior. For example, when you are facing a very stress situation, moments, people are laughing together, even making a joke and so on, just to relax a bit this very intense situation. And so, but our robot is not occupied with laughing. It's a very complex problem. There is a European project on laughing. So there is no, and at the first experiment it was not noticed, but as we lower, in fact, the level of yuck responses, this emerged as a very important way even to reproduce. Even to reproduce. First, autonomous behavior, if you have question. So just the conclusion, so we try to, as I said, undo human-robot with social skills by immersive teleoperation. It's our proposal. So this idea of transfer learning from the pilot to the robot. We try to train incremental behavioral models. With this key issue, the key challenge is how to model style. So to say, I look at the person, he's sitting in the chair. Oh, he looks not so bad. He has not shaking behavior and so on. So I will opt for to say a style very directive interaction. She's a bit shaky and so on, very old and so on, sitting there. I will calm down my behavior and so on. So I trigger an appropriate model, and the idea is to be able to reconsider or to evaluate the distance between the model I've loaded and the actual data I am following. This concept of model follower. To be able to, at a time, say, no, I have to reconsider my a priori. She's shaky, but cognitively is no problem. And so to be able to trigger the good style, but this problem of coordination issue within and with the other person, triggering appropriate gestural controllers, and this idea of how to evaluate interactive behavior. because each interaction is unique, as you know. Open questions. This problem of transfer learning. What about new tasks? Can we? That's one of the physics, the objective of physics of OMA. What about a new subject, new robots? Can we transfer the learning? And of course, ethical issues. So what I said, but perhaps we can discuss this in the late evening. We're supposed to have an open bar discussion. For me, the ethic, I'm a citizen, so I have ethical. I can discuss about ethics around a beer, no problem. But as an engineer, we should inject something in this debate. And what my modest contribution will be to take benefit of this model follower. Okay, to be able to rate the competence of a robot into coping with this interaction. He has model of interactive behaviors. So he has expectation about what. So he's following. In fact, this model is a model of interactive behavior, so joint behavior. He's able to follow the signals. When he detects strong deviations, he should be able to say stop. I'm non-competent anymore, so either to have be able to go back on the tracks, or like a red button saying stop it. I need more training. I need to go back to my pilot to teach me how to cope with you. But I think that's we have. You know that every robot has a red button. I can explain where is the paper one, just behind the neck. Okay, so it's tricky to have access to it. But for iCube, we have a real physical red button. You know this. So the idea is to invent a red button not only for physical protection but also cognitive protection. So take home message: full body information interoperation, short-term interaction to cognitive and physical coaching, and of course the big challenge is now it's, as you mentioned, out of the lab experiment. Because we are bringing the elderly person to the lab, when it will be time to go out of the lab. And I think the HAY conference is perhaps too much ahead of what we are able to do. There is no HAY people, so no problem. Thank you.
Thank you.
Thanks for the presentation. I have two questions. One is immediately linked with the conclusion, means what you call open points or open questions. So I believe humbly that probably the first is the mixture and the confusion today as it has been 30 years ago with neural network, when everybody put two or three balls and call it neural network, mixing it with graphs and anything. I have the impression that today the same happens, and over your talk, it was quite visible with the notion of social behavior. I have impression that many people put everything in social behavior from the moment that it became interactive. But is an interactive behavior absolutely social? That is the problem. Is where is the border? I mean, what you show, for example, the coach, means you can be coached by a TV, by a screen without any interaction. So, is it social?
So perhaps I can answer to the first question before the next one. You need a second. Okay. No, but For me, the challenge, you're right, in fact, just to be able to drive, in fact, a human being doesn't mean that you have a social behavior. For me, it's what is very important is that it's a listening coach. So he is able to have intention, so he has a task to perform. He has, and he's able to decode intention of my challenge is to the social skills I want to embed into the robot is this capacity of how to adapt, to switch between socio-communicative skills. So for me, it's perhaps just very modest, but it's already a way to evaluate the social aspect of interaction and to be able to modify the way the interaction is performed. And this is done by indexing these different models with somehow not social parameters, but because they are still task specific, but somehow to build this style, we inject into this analysis social estimates of the as I said, a priori, and the social links we want to build. It's very modest. It's not, perhaps it's not convincing for you, but it's for me, it's a key issue is social adaptation. So how you adapt, not the only with this precise individual where you don't have any, in 2 or 3 minutes you don't have. So you have some. You relate this individual to a social or to a class of individual. So when you are doing this mapping, you have already addressing something which could be called social. That's my opinion.
That is my now second question. In fact, the gesture is an important issue for, let's say, adaptive interaction. Still, and once again, why absolutely you want to call it social? Because here you don't have emergence of collective behavior, which is probably the first step of something social. So why here everybody today absolutely want to call a smart or adaptive or context adaptive interaction absolutely social. Social is still, well,
yeah.
a very high level, means of interaction, means another. He embeds something from collective, something from interactive, and so if it is smart, if it is adaptive, if it is, why it absolutely should at this stage be social?
Because it's exploiting social, how to say, the data mining we have performed to train these adaptive behaviors is informed or uses some a priori, how to say, estimation of social features. Social features.
Human, but
yes, I'm speaking of myself. But it's not only communicative or interactive behaviors, because it's really, interactive behavior could be very reactive with no computation of any intentions, desires, or belief. Here we try, I think my colleagues will share, I suppose, we try to build up some how to say, some internal parameters, or to estimate, in fact, from the interaction, to extract some hyperparameters which are connected to social settings. To abstract a bit, so it's not perhaps as high level as you will dream, but it's already a start. Yeah.
In the collection of the data, so the pilot is interacting with the patient through the avatar, and so you generate corpora of pilot control signals and perceptual signals that come from the eyes, and the ears. Yeah. So you have these corpora, and you do your machine learning, but then it seems like you must have some challenges related to event segmentation and knowing how to apply this learning back into a situation. Like, so do you have an example? For example, that okay, here's a case where we learned that when the pilot perceives some certain kind of situation, they generate a response, and here we see this in the learned behavior.
So just for me, what we have learned experimenting on LSTM with Omar for almost 1 year is that current LSTM stuff should be fed and produce discrete representation, or so somehow density probability functions, Hotek codings, and so on. It's very difficult. We were still trying to input and output continuous function. So our input and output is discretized.
Okay.
Okay, so we treat events, as I said, we spell this word, that's what you are doing, in fact, somehow. But we have timing information compared to what you have been doing, where you have perhaps just a serial order. We have timing information, which is activations, on-off activation.
And so that event segmentation, do you have tools to do that, or you do that by hand, or?
Both.
Okay.
But we are very heavy users of Elan, so we
and then while
we produce cores.
In the dual user problem, is that so? It seems like it's probably challenging for the neuropsychologist to come in and say, okay, I'm going to immerse into this robot and do my job. What kind of observations do you have about that?
Well, it's very classical. It's this problem of delay. The control loop is typically, especially for gaze, where you have the saccades could be very quick. So you have we are working on Kalman filtering, extended Kalman, to be able to detect saccades which are very fast, and so to have a very high gain with fixations where you have to smooth out, because if you are your neural adaptation, which is favored by microsaccades, if the microsaccades are too much delay in time, you have a flickered image. So you have really to have a very stable on fixation, a very stable image. So yes, the typical delay for gaze for now is 100 milliseconds, which is about the same for the head motion and so on. And it's still a bit. People can compensate after 3 minutes. But before 3 minutes, it's really a strong impairment.
And so then they feel pretty fluid.
Yeah. So the experiment we are conducting is really with people which are with no virtual reality experience. So we just do a very quick calibration with SME is very quick with three points. And they go in the yeah.
Of course, I'm impressed, and I fully agree with your approach to go towards more realistic human-like behaviors.
Yeah.
But I play the devil's advocate. So if we go in this direction, we end up with androids. And are you proposing an android approach? In addition to the behavior, you get the full face.
No, I'm not.
I know, but
when I participated in the Equipex in France, so we had 300,000 euros to spend. Ishiguro came to Grenoble to do a league, very brilliant talk. It's not so brilliant. Anyway, so, and he came to my lab for an afternoon. So I did a lot of discussion of it. I completely disagree with this approach. I think here it's clearly a robot. There is no ambiguity. There is no, we are not in the uncanny valley. And so people have to be very comfortable with the interaction. I don't, that's what I mentioned, is as you are beginning to have more and more convincing socio-communicative skills, interactive skills, people are much more and more demanding about these fine details. So I think we need to reach a equilibrium point and not to go perhaps it's uncanny reach. It has been claimed that you are not forced to go in the valley. You can perhaps be on the ridge in order to see what the Ishiguro stuff here. But I don't think it's. I think there is an optimal. So I'm okay with this. I'm just missing eyeballs. The next is to just have eyeballs. There are 2 microcontrollers just for eyeballs. We are ready. We are just missing the day for asking. But it's very strange because this new help, not so much people are demanding about this. Perhaps we are. So it has been sold to Sheffield because it's a friend of us. But nowadays, you came to the IQB school, and they say we are not trying to develop any further the facial the new IQB. Very strange, but it's okay. No competitors, so no problem. Yeah.
The last one.
The last one.
Thank you,
Gérard. Just one question regarding the way you imagine future works from where you are. I mean, you are training robots through pilots.
Yeah.
So one probable future would be to have many pilots for one kind of robots. So you create a corpora of data for these robots. And another probable future would be to have one single pilot, but for many robots, like Pepper, Nike, and so on. And I mean, I'm not really comfortable, and I don't really understand how your work can be, used in all these probable futures. I mean, how can you scale with this learning you are creating today?
Of course, there is this transfer learning problem across robots. I believe that I think it's always better or simpler to impair, in fact, the demonstration than just to enhance a little demonstration. So the idea is to have IQB is for me is not perhaps the optimal, but it's a large scale of possible behaviors. And after to have these resources of interactive behaviors and to be able to scale down these interactive behaviors to robots which are perhaps less
So are you kind of clustering some behaviors?
Yeah, my challenge is really one-to-many, as I said. So to be able to study, I just mentioned that for me, there is some kind of, I think I will agree with somehow with Peter about this, to say patrimonial aspects. The robot being able to capitalize episodes of life of people, or also to say behaviors. Okay, you know this pizzaiolo ERC, which try to capture all the ways pizzaiolo behave across Italy. So we can imagine of a robot being some kind, like Wikipedia, okay? Wikipedia, which centralizes, in fact, encyclopedic knowledge from all over the world. But knowledge is not embodied. So a robot could be a way to also embody, in fact, the the knowledge of our civilization. Well, it's really, very ambitious, but you asked me, so I'm entitled to do this. But the idea is to deposit, for example, training students. I collaborate with people doing social science, and they want to understand what is the impact of training on screening. Because, for example, to conduct this test, you have clinicians, neuropsychologists, you have people doing, urgents, urgentists, okay? And they conduct the same test in a very different ways. And so it could be a way also to train the robot to have this different style on their side, and to be able to train students saying, if you will be an urgentist, that's the way you could behave, and so on. So to be able to, with one individual, the same incarnation, the same embodiment, to have a panel or a repository of possible behaviors regarding a certain situation, which perhaps just a human or a set of humans will not be able to demonstrate on site. We'll see.
I would suggest
A dream.
continue this exciting discussion.